When you build complex products, you're going to have problems. And those type of problems need to be identified and corrected. And to do that, you have to have a means of doing that. We use our Quality Assurance Center, our QAC meeting, daily to feed back the problems that we had on the prior shift and the prior day. All departments attend that meeting. They're given responsibility for issues that they have to work on and feed back and take care of in their own departments. This is important to not only just feed back problems, but also to finally knock that problem down so it doesn't recur again.
Repair associates was explaining to me that they had trouble with the trunk seal falling off. I have a sample here, car, that we want to take a look at. Take a look at the car. I want to show you.
Great.
So here, Mark, this is the current situation that we have. You notice how this trunk seal is coming up off the flange. It's not staying down on the flange. That's where the 24 units come into effect. Is there any countermeasures that we can put in place to stop this? Have you got a hold of the supplier? Or?
Yeah, what I think it is, Dan, is we have two sets of feet on the trunk seal. We have the sponge feet, and then we have the dense feet. I found the dense feet and the foam feet aren't touching. Okay? So when that actually sets on the flange, it creates a loose condition, so it's easy to pull off.
I see.
So let me give Dennis's in-house sorting, let me give him a call and get him down here and we can show him what we have and get him sorting line side.
Alrighty, thank you, Mark.
Every manufacturing process has their own quality characteristics. And what I mean by quality characteristics, they are the type of things that typically go wrong with those processes. The activity to take care of these problems is more of a proactive approach or a preventative approach versus a reactive approach. If you simply wait and react to a problem, then you're going to be dealing with nothing but problems. There's quite a few examples of that that you'll see. One of those is at the beginning of our assembly line, we take the doors off of the car. The associates get in and out of the cars frequently, and in doing that they have the risk of chipping or scratching the paint on the car. This prevents that from happening. Another example is that we put a white plastic film on the cars for shipping protection. But instead of waiting until the end of our process before we ship the car to put that protection on, we put that on in our paint department so that in our assembly department we don't get chips and scratches on the surfaces because the white plastic prevents the product from being scratched. Also, we go back into the design of our product. Deforms are a big issue for us in manufacturing. If we improve the material that is used, make the material more rigid, then the car has less opportunity to be deformed. And that's another form of proactive or preventative activity that we take. So in looking at manufacturing processes, you have to take a very proactive approach to prevent problems that you know will exist in your process. In manufacturing, you're always trying to find ways to do things better, more efficiently, and the bottom line in trying to improve quality. We call this continuous improvement. We have a lot of examples of that, but one of the best examples we have is with our welding A-zone. In our welding A-zone, we have literally replaced 50% of our welding department that is only 10 years old. And the reason for replacing that is because technology has advanced, and we have the ability to improve our process efficiency and at the same time improving the accuracy of the product that we build because of the technology of the robotics and the equipment that we have installed. The result of that is not only improved production efficiency, but we actually have improved the accuracy of our product and the consistency of the product, which is really what quality is all about.
Actually, you can go through the entire profile, looking down into this area to make sure we can't see down into the C dimension. But you have to make sure you do the entire length because this problem is so sporadic, it won't be in the whole part. It'll only be certain sections, maybe 100 to 150 millimeters in length.
Okay.
Then we need to record the good and no good ones on the sort sheet. Okay. Location, line side, lot number, which is what we're currently on. Production date, which we'll take off your container. Color, there's no color on this part. The OK, and the scrap. We won't have any repair, we're just going to scrap all the no good ones.
Okay.
Then when you're complete with that, you take these re-inspection stickers, place one on each end of the tub. I completed one to show you how they need to be completed. I'll let you do the remainder of them.
Okay, Mark, what I need from you is a good sequence number when you start guaranteeing the parts to me so I can give that number back here to the production side.
Okay,
That's going to be the good number, 19?
yeah, Dan, this will be the first good sequence number, 19733. Everything else after that should be fine, shouldn't have any problems.
Okay, thank you very much, Mark. I'll get back with you if you see any other problems.
Okay, thanks, Dan.
Thank you.